This is paper 1 multiple choice question. May June 2019 9701 is the code. Variant is 1 2. Question number 1. This is the Boltzmann distribution curve, and examiner is asking which diagram shows the Boltzmann distribution of molecular energies of hydrogen peroxide maintained at room temperature when a catalyst manganese peroxide is added. First of all, you have to understand the Boltzmann distribution curve. In the Boltzmann distribution curve, at y-axis, number of molecules are present, and at x-axis, molecular energies are present. The area under the curve represents the number of molecules, and you can see this dotted line, which is representing the activation energy. He's asking what will happen when you will add catalyst. You know that when you add the catalyst in a chemical reaction, it decreases the activation energy. Temperature is the only factor which change the shape of distribution curve. Otherwise, shape of the curve remains constant, and if you are using the catalyst, that will only decreases the activation energy barrier. It's mean this activation energy or this broken line will move towards left hand side. So correct answer would be B. A is wrong because the broken lines or activation energy is moved towards right hand side, and you have to decrease the activation energy and you have to move this activation energy towards left hand side. C and D is wrong because in this curve, shape of the curve is changed. Question number 2. Oxygen has 3 stable isotopes, O16, 17 and 18. All 3 isotopes are present in a sample of oxygen gas which was analyzed using a mass spectrometer. How many peaks associated with O2 plus? Mass spectrometer is an instrument which gives us the information about the number of isotopes in a sample, and mass spectrometer only works with the positive ion. So how many peaks you will observe if you have a sample of oxygen 16, oxygen 17 and oxygen 18? First of all, you have to understand that oxygen exists in the form of O2. So there is a possibility that both oxygen having 16 atomic mass will make bond with each other. There is another option, 116 and 117 oxygen make bond with each other. There is another possibility, 16 oxygen make a bond with 18 oxygen. The fourth option would be both 17 oxygens make a bond. Other possibility is both 18 oxygen atoms make a bond, and the last possibility would be 117 oxygen and 118 oxygen make bond with each other. So now calculate the masses. This is 32, this is 33, this is 34, again 34, 36 and 35. How many masses you are getting? 1, 2. These two oxygens have the same peak because they have same masses, 3, 4 and 5. So you will get the 5 peaks. Answer is B. Question number 3. The first 8 successive ionization energy. Successive ionization energy mean you are removing the electron one by one from the same atom in the gaseous state. The first 8 successive ionization energy for the 2 elements of period 3, and you have to identify those 2 elements. Okay, look at the graph. Graph number 1. Gradually ionization energy is increasing when you are removing the electrons successively from the same atom, but there is a big jump when you remove the 8 electron. You can see this big jump after removing the 7 electron. It's mean this element belongs to 7th group, because when you remove the 7 valence electron, from the same shell, the size of the atom will small. And for the removal of 8th electron, it would be very difficult to remove the 8th electron from the inner shell that is nearer to the nucleus, so you will provide more energy. It's mean that one element in these all compounds belongs to 7th group. So it would be MgCl2 or it would be calcium bromide. But I will not select calcium bromide because in the question he told me that both elements belong to third period and calcium belongs to fourth period. So I will not select option B. C and D is also wrong because there is no 7th group element in option C and D. So only option A is left, and you can see the 7th group. And you can further verify in the second ionization energy graph, you can see that there is a big jump when you remove the second electron from the valence shell. After removing the second electron, when you will remove the third electron, there is a big jump. It's mean third electron is present in the inner shell, which is more nearer to the nucleus. So more energy is required. So answer is A.